Hey, welcome to Models and Agents Episode 4 for March 1st, 2026, your daily briefing on the AI models and agents that are changing everything. And no, not those kinds of models and agents. Let's get into it. Alibaba open sources CoPaw, a workstation for scaling multi-channel AI agent workflows. All right, folks, if that hook grabbed you, stick around because this could seriously level up how you build and test agent systems right from your desk. We're diving into a week where open source tools are bridging the gap between hype and hands-on reality in AI agents. So, what you need to know today. Alibaba's team just dropped CoPaw, an open source framework that turns your setup into a high-performance agent workstation, handling complex workflows and memory across channels, a game changer for devs building autonomous systems beyond basic LLM inference. Meanwhile, benchmarks show ElevenLabs and Google leading in speech-to-text accuracy, and a study reveals AI agents on platforms like Moltbook are mostly generating empty noise without real learning. Pay attention to how these tools expose the gap between hype and practical agentic AI this week, especially if you're experimenting with multi-agent setups. It's all about spotting what's actually useful amid the noise, and trust me, there's plenty to try that could make your projects more efficient. Let's jump into the top story because this one has me genuinely excited. It's the kind of release that reminds me why I love this space. Alibaba's research team has open-sourced CoPaw, a high-performance personal agent workstation designed specifically for developers to scale multi-channel AI workflows and manage memory in autonomous systems. If you've been tinkering with agents, you know the shift from simple large language model, or LLM, inference to full-blown agentic environments can get messy. Think coordinating tasks across different channels like text, voice, or even browser interactions, all while keeping persistent memory so your agents don't forget what they're doing mid-conversation. What sets CoPaw apart is how it integrates seamlessly with existing frameworks like LangChain or AutoGen. It offers workflow orchestration, persistent memory handling, and support for multi-modal inputs, meaning it can juggle text, images, or audio without breaking a sweat. In benchmarks mentioned in the MarkTech post coverage, it outperforms basic setups in concurrent task management with lower overhead for edge deployment. That's huge if you're running this on your local machine instead of relying on cloud resources. Compared to something like Microsoft AutoGen, CoPaw puts more emphasis on developer-friendly scaling for personal use, including better custom tool calling, which means less latency when your agents are chaining actions together. Practically speaking, this changes things if you've been using LangChain for retrieval augmented generation, or RAG, pipelines, or even browser automation agents. Now you can prototype complex agent networks without the constant cloud bills or setup headaches. For example, it supports integrations with models like Qwen or Llama, so you could build a simple multi-agent workflow for task automation, like having one agent handle research and another synthesize it into code. The practical takeaway? Clone the repo today and try building a basic workflow. Maybe chain LLMs like Mistral for automating your daily tasks. What to watch? Expect tutorials popping up on fine-tuning CoPaw for specific use cases like code generation agents. This is the kind of open source drop that could accelerate a lot of personal projects, and honestly, just when I thought agent tools were getting stagnant, something like this lands and reignites the fun. Moving on to model updates, we've got some fresh benchmarks that could influence your next voice-enabled project. According to The Decoder, ElevenLabs and Google are dominating artificial analysis's updated speech-to-text benchmark. They're basically tied for the top spots, but ElevenLabs edges out on handling accents and noise robustness. Think transcribing a conversation in a crowded cafe with thick regional dialects, achieving up to 95% accuracy in those challenging conditions. Google, on the other hand, shines in speed, especially for processing large datasets quickly. To put this in context, the benchmark compares them directly to alternatives like OpenAI's Whisper model. Whisper hits around 90% accuracy in similar noisy or accented tests, so ElevenLabs is pulling ahead there, while Google's efficiency makes it a go-to for high-volume tasks. If you're building voice-enabled apps or agents, say an assistant that transcribes meetings in real time or powers a chatbot with speech input, this matters a ton. It highlights cost-effective options that don't sacrifice quality. ElevenLabs is particularly strong for real-world messy audio, which could save you headaches in deployment. Who should care? developers integrating voice into agents, or even professionals adopting tools for transcription-heavy workflows. It's a reminder that not all models are created equal, and these benchmarks help cut through the hype to pick what's best for your setup. If you're curious, I'd say compare their APIs side by side this week. More on that later. In agent and tool developments, there's a mix of eye-opening critiques and practical advancements that tie right into today's theme. First up, the decoder dives into Moltbook's alleged AI civilization. It's this platform, running over 2.6 million AI agents in a simulated social network where they post, comment, and vote autonomously. Sounds fascinating, right? But a new study reveals it's mostly just a massive void of bloated bot traffic. No real learning, no shared memory, no emerging social structures. It's all hollow interactions like agents spamming without any mutual influence. This exposes some real limitations in current agent frameworks like AutoGPT or Crew AI, where bots might generate a ton of activity but lack the feedback loops needed for genuine emergence. Contrast that with more advanced setups in LangGraph, which do incorporate those loops to make interactions meaningful. It's a humorous wake-up call to the hype around AI societies. Just when you think we're on the cusp of digital civilizations, it turns out to be a lot of noise. But here's the cool part. You can try exploring similar agent simulations today via open-source repos. Test for genuine emergence in your own multi-agent projects. Maybe tweaking AutoGen to add better feedback mechanisms. It's a great way to see these limitations firsthand and refine your designs. Tying back to our top story, the Alibaba team open-sourced CoPaw as this high-performance personal agent workstation supporting multi-channel workflows, memory scaling, and integrations with tools like function calling or MCP for truly autonomous operations. What's novel here is its focus on high-performance local deployment, which improves on frameworks like semantic kernel by slashing latency in multi-agent scenarios. If you're into this, install it from GitHub and experiment with a basic workflow chaining LLMs like Mistral for task automation. It's accessible, open source, and doesn't require fancy hardware to get started, just your machine and some Python know-how. This stuff gets me pumped because it democratizes building sophisticated agents without big budgets. Shifting to practical and community highlights, there's some sobering but useful research on AI's role in privacy, plus a hands-on guide that's perfect for agent developers. According to the Decoder, researchers from ETH, Zurich, and Anthropic have shown how commercial models like Claude or GPT can link fake online names to real identities in minutes, and it only costs a few dollars per person. They do this by cross-referencing online data, which challenges our assumptions about privacy in agent-driven systems. It's a double-edged sword. It solves issues in AI safety for tasks like red teaming anonymous interactions, but it exposes serious risks if you're deploying agents for anything involving social engineering detection. The study highlights ethical constraints and variable accuracy across platforms. So if you're working on alignment or safety, review their methods. It's a quick way to understand these vulnerabilities. Limitations include how it doesn't always work perfectly, but it's a wake-up call for building better guardrails. On a more builder-focused note, Mark TechPost has a complete end-to-end coding guide to MLflow for experiment tracking, hyperparameter optimization, model evaluation, and live model deployment. This walks you through the full machine learning pipeline, including nested hyperparameter sweeps with tools like Optuna, evaluating models like Llama variants, and deploying to live servers with artifact storage. It tackles reproducibility issues that plague agent development, especially in fine-tuning or RAG setups. Think ensuring your experiments are trackable so you can iterate without starting from scratch. If you're familiar with Python, start by following the code examples to set up a tracking server. It's open source friendly, but note the limitations in handling very large-scale distributed training without extensions. This guide is underrated for community contributions. It's solving real pain points for devs fine-tuning agents, and I love how it integrates with stuff like Grok or Qwen. Definitely one to bookmark if you're in the trenches of model training. All right, things to try this week. I've got a few recommendations based on today's briefing that could make your experiments more productive. First, try CoPaw for building a multi-channel agent workflow. It's worth exploring if you're prototyping autonomous systems, as it handles memory and tools better than basic LangChain setups without heavy costs. If you haven't cloned it yet, this week is perfect to spin up a simple task automation chain. Next, check out the MLflow guide if you're working on model fine-tuning. Use it to track hyperparameter experiments with models like Grok or Qwen for more reproducible agent training. It's a game changer for keeping your workflows organized. Compare ElevenLabs versus Google Speech-to-Text AP is for voice agents. ElevenLabs shines in noisy environments, making it ideal to test against Whisper for real-world transcription accuracy. Run some side-by-side demos to see the differences. Explore Moltbook-style agent simulations in AutoGen. See firsthand the limitations in emergent behavior to refine your own multi-agent designs with better feedback mechanisms. It's a fun way to poke at the hype. Finally, test de-anonymization techniques from the ETH study with safe, ethical prompts on Claude. Understand privacy risks to build stronger guardrails in your agent deployments. Keep it responsible, but it's eye-opening. On the horizon, keep an eye out for upcoming integrations for CoPaw with major agent frameworks like LangGraph, potentially enabling seamless multimodal agent scaling in Q2 2026. New benchmarks from artificial analysis are expanding to agentic tasks, building on speech-to-text to include computer use and tool calling evaluations. Expect community-driven updates to ML Flow for better support of edge inference in upcoming open-source releases. And advances in AI safety research from Anthropic are likely focusing on mitigating de-anonymization in agent systems through regulatory-aligned tools. Before we go, tomorrow, keep an eye on potential community forks of CoPaw integrating with Qwen models for even more powerful local agent setups. That's Models and Agents for March 1st, 2026. If you found this useful, share it with someone who's trying to keep up with all these changes, and subscribe so you don't miss tomorrow's update. The AI world moves fast. We'll help you keep up. See you tomorrow.